Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 1, Trigonometric Functions of Acute Angles, Video 1, From Coordinate Plane to Right Triangles. The series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous chapter, we learned about the 6 trigonometric functions as defined for an angle in standard position in terms of a point on the terminal side. Specifically, if theta is an angle in standard position, vertex at the origin, initial side on positive x-axis, and xy not equal to the origin is a point on the terminal side of theta, then here's our 6 definitions of our trig functions, where r is the distance from the origin to the point xy. These definitions allow us to study trig functions of any angle, positive or negative, of any size, since we can rotate beyond 360 degrees. However, in many real-world situations, we're only interested in triangles where the sum of the angle measures forces all such angles to be in the interval 0 degrees to 180 degrees. In other words, acute and obtuse angles and right angles. As such, is there a way to remove the trig discussion from the coordinate plane and focus solely on triangles? In other words, can't we do trig without the XYR construct? Of course, the answer is yes, and the transition from coordinate plane trig to triangle trig is rather intuitive. Initially, we focus on acute angles. In the next section, we consider obtuse angles. Consider the following diagram of an acute angle theta. For such an angle, we always have x is greater than 0 and y is greater than 0. We get r is greater than 0 for free. Because it's an acute angle, on the coordinate plane, it would be in quadrant 1. And this is the picture that we've seen many times before. To remove the coordinate plane aspect, we need to rename the sides of this triangle. We need to name them independent of x and y and something more pertinent to the angle theta. In this right triangle, the side we normally call x is adjacent to theta. So we will label that side adjacent, or ADJ for short. Also, the side currently labeled y is opposite theta in the sense that it is not adjacent to theta. If you stood in the corner where theta is, put your hands on the adjacent sides, and looked into the triangle, you'd see the opposite side marked y. Thus, we will refer to the side normally called y as the opposite side, or OPP for short. But what about the hypotenuse, which is currently labeled r? Well, we'll call it the hypotenuse, of course, or HYP for short. With these designations, our picture transforms from this to this. X becomes adjacent, y becomes opposite, r becomes hypotenuse. Essentially, we made those changes. As a consequence, our trig definitions change from this, the x, y, r definitions, to this, the opposite adjacent hypotenuse definitions. These are our right triangle trig definitions. Memorize them. It's easier to memorize the top 3 and then capitalize on reciprocal relationships. But if you have the XYR definitions memorized, the transition to these is easy. Just change X to adjacent, Y to opposite, and R to hypotenuse. Now, caution, it is vital to remember that adjacent and opposite are in reference to a specific angle. For example, what if we were referring to the angle at the top? Well, if we were, the location of adjacent and opposite would switch. Hypotenuse is always the same. So be careful when you're looking at a certain angle, who's adjacent and who's opposite is relative to the angle that you're looking at. With right triangle trig, we do not concern ourselves with angles being in standard position, since that is a coordinate plane concept. As such, our triangles and angles can be oriented in any way as long as we pay attention to who's adjacent and who's opposite. One last comment about our new perspective. Many students learn a gimmick that helped them remember the definitions of sine, cosine, and tangent, called SOHCAHTOA. It's a nonsense word, but many people remember it. SOHCAHTOA represents the 9 initials in the definitions of sine, cosine, and tangent. Specifically, SOH stands for sine equals opposite over hypotenuse. CAH stands for cosine equals adjacent over hypotenuse. And TOA represents tangent equals opposite over adjacent. So if SOHCAHTOA works for you, more power to you. If you have a cool gimmick, I'd like to hear it. Once sine and cosine and tangent have been established, the definitions of cosecant, secant, and cotangent are formed via reciprocal identities. Now you try. Pause the video and try the following. Number 1, when transitioning from the coordinate plane definitions to right triangle definitions, what does R become? What about X and Y? And number 2, which trig function is defined as each of these ratios? Pause the video, give them a try. All right, fair warning, if you haven't paused the video, solutions in 3, 2, 1.